Hi, my name is Davidson, and I'd like to tell you a bit about adaptive authentication. So we'll take adaptive authentication as a product, specifically in a use case of the financial institution. So before I can tell you about the product itself, we need to understand what currently end customers are doing when they are transacting with the bank. So let's take, for example, an end user and his current session with a bank. So this would be the user. This is the bank's session, a financial institution basically, and this is the RSA system of adaptive authentication that currently is not installed at the bank site. So first, the user, when he comes to log into the online banking of this specific bank, he would ask for a login page. The bank will send him back the page, and this is where the session basically begins, is where the user would put a username and a password, and then would send this information to the bank. The bank would then verify the username, the password, maybe even the one-time password of this specific user, and assuming that everything turns out to be right, he would send back a success page. Success. Now, from that success page, the end user can go to a payment or any other type of transaction that he would like to do. Let's assume that the user wants to transfer $100 to a beneficiary. So he would then get the payment page and transfer $100, and will send this information to the bank. The bank would then check that the account has enough money in it, that this user is allowed to transfer money, that this user is allowed to transfer money to that specific beneficiary. And once all this is done, he would then inform the end user that his transaction was also successful. Great. Now, let's assume that this end customer also had some kind of Trojan or man-in-the-middle attack that jeopardizes his system. The bank in this case might have actually lost the money because this might not be the genuine customer. In this case, let's assume that the bank had actually implemented an adaptive authentication system. Then, once the user had logged in, the bank, before allowing the user to log in into the system, would actually send a request to RSA for risk assessment. RSA, a risk engine that is a Bayesian risk engine, would then assess the risk of this specific transaction based on the user's system, based on the user's behavior, and so on. And assuming that the risk score is low, he will tell the bank this transaction should be allowed. And then the bank will allow the user to log in. The same would basically be with the transaction itself. Now, let's assume that this is an adaptive authentication system. Then, once the user had transferred $100, again, the risk engine starts working, checking behavior, checking the system, and so on. If the system was compromised, then most likely now it's a fraudster that is transacting on behalf of this user because he got the credentials via a phishing or a Trojan. And he's now transacting from a different machine probably. So the machine behavior will be different, and therefore the risk score will be high. If the risk score is high, RSA will inform the financial institution, oh, you should actually authenticate the user. Once authentication begins, and authentication can be either out-of-band phone, SMS, a one-time password, email, or any other type of authentication, then only if the user would answer correctly the PIN on his phone, his transaction will then be allowed, and again, the transaction will go through. Now, risk score. So how is the risk score built? The risk score is being generated within the risk engine, and the risk engine is a Bayesian model that that gives basically higher weights to recent events, and takes into consideration different types of data elements and information, either from the eFraud network or the behavioral analysis of this customer or the general population of the bank or the market. The risk score is normalized between 0 and 1,000. where the normalization is done in such way that we know in advance that for risk score 900 and above, you would basically have 0.25% of the most riskiest transactions flagged. Risk score of 700 and above, for example, will have 1% of the most riskiest transactions. Now, within those 0.25%, you may have 80% of the bank's fraud or 90% of the bank's fraud, let's say 80. And within 1% of the most riskiest transactions, you would probably have around 95% of the bank's fraud. And then the question that the fraud team within the bank needs to decide is basically, where do we want to challenge the end customers and basically have either a challenge question or an out-of-band phone. Let's say that we want to do that at 850 for phone authentication. And don't forget that phone authentication has also cost associated with it. And for risk score 700 to 850, we would use secret questions. Then all of that would be done within the policy manager. So the policy manager basically allows you to write different types of policies that are usually based upon risk score and additional data elements, such as whether the specific IP of the transaction is within the eFraud network, was it already used for a certain fraud pattern before, whether the account was ever used as a bait account or as a mule account previously, and so on. So you can write all of these policies, and based on these policies, basically, what would then happen is different cases will be opened within the case management. Case management is the system that is basically used by the fraud deterrent team to look at cases. These cases will usually be either cases that are based on failed authentications, and then you would have here case 1, 2, 3. These will be, the view itself will be optimized according to the sending order of the risk score, so that you would attend the higher risk first. Risk also takes into consideration amount and so on. And then also you would have cases based on transaction monitoring, simply those transactions that were flagged. You did not want to authenticate them, but you did want to review those cases, and then you would have here cases 30, 31, 32, and so on. So we've basically covered the main features of the adaptive authentication system. Based on a certain fraud pattern, you will either be authenticated or a case will be created so that the fraud deterrent can then review, contact the end customer, and flag the system whether it is fraudulent or not. Based on this flagging, a feedback will go back into the risk engine so that the risk engine can then optimize itself for the next transaction. I hope that I was clear enough. Thank you very much.